Hello students and welcome back to my channel. Today we are discussing questions which were asked on the 1st of February 2023 JEE Mains. Okay, this video is in continuation with other videos. You can kindly check the other videos. Okay. So this question 33, the equivalent resistance between A and B of the network shown in figure. Now students, you see whenever you come across this kind of an arrangement, that is arrangement of 5 resistors, most probably it would meet the requirement of a Wheatstone bridge, balanced Wheatstone bridge. So how is it? See, it is like this. Okay. See this. This R I am marking here. This 2R I am marking here. This 3R I am marking here. And this 6R I am marking here. The middle one is 9R. This is terminal A, whereas this is terminal B. Now you see, it is satisfying the condition of a balanced Wheatstone bridge. R by 2R is half, 3R by 6R is also half. That means what? You can simply ignore this resistance, because when you connect a cell across the terminals between which we have to find the effective resistance, namely A and B, then certainly the current which flows through R will flow through 3R, and the one which flows through 2R will flow through 6R. So this will carry no current, so there is no point in keeping it. So you can simply ignore it. So just ignore it. Now you have a combination of series parallel arrangement, you can see. So here you have this R and 3R are in series. So overall this equivalent resistance will be 4R, whereas these two resistors are also in series. So 2R plus 6R is 8R. So now we have a parallel combination of 4R and 8R. So the effective resistance will be product upon sum. Product upon sum. So you can see 4R 3 is the, so 8R by 3 is the correct answer. D option is the correct answer. Moving to the next question, question number 34. Match list 1 with list 2. Okay. Now you can see in the left list 1 we have certain phenomena of some instruments, apparatus and all, whereas list 2 indicates some phenomena or something related with that. Now as you know, coming to AC generator is basically something which generates power, isn't it? It generates power. Transformer is basically an apparatus or a device which changes the voltage, low voltage to high voltage. That is known as step-up transformer, and high to low is known as step-down transformer. Now resonance phenomena occurs in LCR circuit. Okay. Or it could be a series LCR circuit, or it could be a parallel LCR circuit. Resonance phenomena. And sharpness of resonance is related to quality factor, of course. So D can be straight away matched with 3. Okay. Then what you call transformer is based on mutual induction. B should be matched with 4, because there is a mutual induction between the primary and secondary coil. We all know that transformers have a primary and a secondary coil. The input voltage is applied across the primary and output voltage is obtained across the secondary. So it works on the principle of mutual induction. Then we know resonance phenomena to occur, it is necessary that it should be either a series LCR circuit or a parallel LCR circuit. And AC generator is based on Faraday's laws of electromagnetic induction. So A is matched with 2. So A with 2, B with 4, C is matched with 1, and D is matched with 3. So C option is the correct option. Moving to the next question. Equivalent resistance between adjacent corners of a regular n-sided polygon of uniform wire of resistance R would be. So you have to understand, students, that initially the wire is a straight wire. It is a straight wire of resistance R that is given. Now this is bent, okay, to form a polygon, this kind of a thing. So if you have a polygon, regular polygon of n sides, n can be anything, okay, and let us say that the resistance of each portion is small r, which will be of course capital R by n, because you know resistance is proportional to length, rho L by A. Since here the length has been equally subdivided because it's given as regular n-sided polygon. So length of each part is 1/nth of the original length. So resistance will also be 1 by nth of the original length. So we have to find the resistance between these two. Okay, equivalent resistance between adjacent corners. So now you can see this has a resistance smaller from here to here, whereas the remaining n minus 1 resistors are arranged here in series. So this is 1, 2, 3, 4 like that up till n minus 1 resistors. So all are in series, so we are this. So at the end we have a parallel combination between what? N minus 1 R, this entire thing, I'll show it, this entire thing n minus 1 R and R, the parallel combination of these two. So effective resistance you can obtain as the product upon sum. So product is n minus 1 into R upon n R. 1 R gets cancelled, students. Okay. You can see 1 R and sorry, you replace small r with what? Capital R by n here. So finally we will be having n minus 1 into capital R upon n square. So correct option is the A option, you can see. Okay, n minus 1 into capital R upon n square. Then moving to question number 36. I have to this question 36, you can see. Given below are two statements, one is labeled as assertion A and the other is labeled as reason R. You can see assertion A states that for measuring the potential difference across the resistance of 600 ohm, the voltmeter with resistance 1000 ohm will be preferred over voltmeter with resistance. This is wrong, students, because as we know that ideally a voltmeter should have infinite resistance, because when you connect the voltmeter in parallel with the element across which you are about to find the voltage, the voltmeter should draw minimum current, and that happens if voltmeter has infinite resistance, it will draw practically negligible current. So voltmeter should have high resistance. So here there is no question that a voltmeter of 1000 ohm will be preferred in comparison to 4000 volt. That's not correct. Coming to reason, voltmeter with higher resistance will draw smaller current than voltmeter with lower resistance. This is absolutely correct, and this is what is preferable. So A is incorrect, but R is correct. So we have B option. A is not correct, B is correct. Moving on to the next question, question number 37. Question number 37. A series LCR circuit is connected to an AC source of 220 volt 50 Hz. The circuit contains resistances and an inductor of inductive reactance. The capacitance of the capacitor needed to maximize the average rate at which energy is supplied. So rate at which energy is supplied is nothing but power. Okay, and power is always equal to I square R. Okay, in any circuit, it could be having capacitor, resistor, anything. Okay, the power losses is always in the resistance. So always you have to use this one, I square R. So in order to have the in order to maximize this, so current should be maximum. Current should be maximum. And current is maximum when impedance is minimum. And impedance is minimum when in the state of resonance. So in the state of resonance, we have XL is equal to XC. That is, the net reactance remains 0 here in the state of resonance. Okay. So therefore, we have omega L, we have to know that. So omega L must be equal to 1 by omega C. Is it? So solve. This is already given. XL is already given, students. So just we have to find the value of C. So C will be equal to 1 upon omega XL. And omega is 2 pi into frequency, because they have given the frequency as 50 hertz. So this is the formula which we'll be using here. So 2 into pi into frequency is 50 hertz, and XL is 79.6 ohm. Okay. We have substituted everything in SI unit, so we can expect the answer also in SI unit. So 2 into 50 is 100. 2 into 50 is 100. Now 3 into 8 is approximately 24. So this will actually 250. So this will actually be 250. If you calculate 3.14 into 79.6, it is somewhere close to 250. Now we have to express the answer in microfarad. So micro is 10 to the power minus 6. So multiply and divide by 10 power 6. Okay. So we have here 100 into 100, because 100 will get cancelled here, upon 250 microfarad. So here you have 55s are 52s are. Then 5 into 20. So finally we have 40 microfarad. So answer is 40. It's simply a matter of calculation, students. Okay. Then moving on to the next question. In an experiment to find EMF of a cell using a potentiometer, the length of null point for a cell of EMF this much is found to be 60 cm. If this cell is replaced by another cell of EMF E, the length of null point increases by 40 cm. So certainly E should be more than 1.5 volt. So the value of E is this, the value of X is. Okay. So here I'll just quickly draw a diagram. So this is a potentiometer wire, and this is the cell. Now the cell which is being balanced is this. Okay, and this is the balancing line. Now principle of potentiometer states that the EMF of the cell which is being balanced is equal to potential gradient multiplied by balancing line. That is potential difference across AC of the potentiometer wire, that is across the balancing length of the potentiometer wire, should be exactly equal to the EMF of the cell which is being balanced. Okay. So based on that I can write E2 by E1 is equal to L2 by L1, assuming that potential gradient is constant. Unless and until we disturb these two things. Unless and until we disturb these two things, that is the EMF of the battery which is providing current to the potentiometer wire and the resistance of the rheostat, potential gradient will not change. So in most of the cases, potential gradient remains unchanged. So the EMF will be proportional to the balancing length. So that's all. So let us solve this. So E2 we have to find, which is x by 10. I'll straight away write it as E2 as x by 10. The one which is mounted, x by 10. EMF is already given as E1 is 1.5. 1.5 I can write it as 3 by 2. The new length is increases by 40. Initially it was 60 and now it is 60 plus 40, that is 100. So let us cancel what all things get cancelled, you see. So here 1 0 gets cancelled, 3 2 0. So x is equal to 100 by 4, which is equal to 25. So the value of x is 25. Okay. So 25 by 10 is basically 2 point. Moving on to the next question. You can see in the given circuit the value of I1 plus I3 upon I2, mod of that is given by. So we have to find this expression. So the simplest method I'll teach you students. I'm teaching the simplest method which is applicable to this. This is a special kind of arrangement of. What I'm going to do is that I'm going to take this as grounded, that is having a potential 0. So as you move back this way and you move and you reach this point, you will see that there is a gain of 10 volt. So this must be plus 10 volt potential of this point. Okay. So if you apply KVL straight away to this loop, if you apply KVL to this loop, you will find that from here to here plus 10 and minus I1 10 is equal to 0. So I1 will be equal to 1. Similarly, if you apply KVL to this loop, again you will get I2 as 1 because plus 10 and minus I2 10 is 0. So I2 is also equal to 1 ampere. And here, what we'll do, you see here, as you move from here to here, this is already 10 volt, this is 10 volt, and you move towards the negative terminal, so there is a decrease in voltage by 20 volt. So 10 minus 20 is minus 10, minus 10, minus 10, and as you move against the direction of current, we should reach 0. So there has to be a potential drop of, potential rise of 10 volt, because this is at minus 10 volt. So minus 10 plus 10 will make it 0. So there is a potential drop of 10 volt across a 10 ohm resistance. So I3 has to be volt by 10 ohm, which is again 1. So 1 ampere. So each of them is 1 ampere. So this will be 1 plus 1 plus 1, that is 2. So correct answer is 2. That's all students in this video. Thank you for watching my channel.